Exceptions are not the only way you handle errors. Especially for expected errors, the best thing to do is to just test for them. If the amount to be withdrawn is greater than the amount available for withdrawing, do something, deal with it, put up an error message, tell the user what they've done wrong. Write exactly where you find the problem. That's when you have the most information. But the problem is that in some designs, some architectures, the code that actually finds the problem is a really long way away from anywhere that it can tell the user about the problem, or in some other way recover. So if you're in the user interface and you've just popped up a dialog and you've let somebody choose a file and then you test to see if the file still exists and it doesn't, you can just pop up a message box that says, hey, that file seems to have disappeared in the last 5 seconds. Please choose another one. But if you let the user choose a file and you take that file name and you pass it along to some member function of some business object who passes it along to someone else, who passes it along to someone else, 6, 7, 8 calls down, then they go and open the file, they don't have a really good way to communicate directly to the user. So one thing you can do is have that chain of functions return true or false to indicate if there is a problem, for example. And then all the functions along the way in the chain, they need to test that return value. So if deeply nested function, carry on and do more things, else, well, I'll return false also. And then whoever called me will have to check me to see if I return false, and so on, all the way up the chain. Couple problems with this approach. Some functions we're maybe going to just return void, nothing. So that's fine. You can toss on a return value to them. But what about functions like square root or find employee that are supposed to already have return values? Sometimes people will use signal values. So for example, if find employee returns an employee number, return -1 to indicate there was a problem. Or for square root, you could also return -1 because it has to be positive. Of course, this doesn't work very well with functions that could return a wide value of numbers or strings, all of which are perfectly fine and legitimate values. These signal values aren't always available to you. And if you get into trouble in a constructor, you don't have an ability to return anything. Constructors cannot return. Some people get around that by saying, oh, you know what? I won't ever have my constructor do anything. I'll write this function called init, and it can return true or false, and then I'll always know if there was a problem. That really gives up most of the benefit of constructors for not much gain. Other people will set a member variable in the constructor when it succeeds to say that the object is valid, and then have all their other functions test the valid flag. Boy, that's really awkward. And of course, you open yourself up to people forgetting. They can forget to check that member variable to indicate whether the object is valid or not. They can forget to check the return value from the function. That's a problem. If your error handling relies on other developers remembering to do something, what are you going to do inevitably when they forget to do something? And the more infrequent the errors are, the more likely the forgetting is to happen. So if you think about users leaving things blank, that's going to happen constantly. Developers will remember to check for invalid values on a form. But having your network connection drop in the middle of a process, that's a lot rarer. It may never happen to the developer, and they may never think to test for it. So it's more likely for these unusual errors that people will not be checking return values or in other ways preparing to deal with those unusual situations.